Hi, this is Pete Thompson. Today we're going to talk about electrical safety. Electricity has been around for a long time, as you can say, and it's a big part of everyday life. We're going to talk a little bit about the hazards of electricity and how it works, some of the dangers, and some of the things that we do to make sure that we don't hurt ourselves. Some of the definitions are important. Conductor is a material that can conduct electricity. Includes metal, includes water, includes your body. Insulator is something that will prevent electricity from going through it. Typically, those are the things that you see around the wires for things like plastic, glass and porcelain, also dry wood we'll talk about. An amperage is a measure of how much current is going, how much the electrical current there is. The voltage is comparable to pressure if you think about water pressure, and we'll talk about that. A transformer is something that changes the voltage of the electrical current, and grounding is a way to make the low resistance path be in place so that the electricity, if it gets loose, basically ends up in the ground and not where it shouldn't be. So this is the analogy that I usually use about how electricity works. Basically, electricity is like water. So if you're using electricity, it's like turning on the water faucet. And the water basically always wants to go to the lowest place, is what I say. So the electricity is going to go to the lowest place and the place that is the easiest to go. And if that's your body, it's going to go through your body. A transformer provides the pressure or the voltage for the electricity to go through the conductors or the wires. And typically, as I said, the conductor can be a wire, it also can be your body. So the idea is to keep the electricity in the wire and not in your body. So here's an example of the wires, and you'll see that generally the electricity goes through the wires. Electricity wants to go to the lowest place, just like if you spill a glass of water, it wants to go down onto the ground and into the ground. Electricity wants to do that, and it'll go the easiest way that it can find. So some of the specific things about electricity, you're probably familiar with a ground fault circuit interrupter. And basically what it is it's a quick circuit breaker that will shut off the electricity if it sees that there's some sort of shortage or the electricity is going in the wrong way. And you'll see those either in the workplace as a separate thing in the wire, or typically often anywhere where there's water, there'll be a ground fault, a GFCI also. OSHA wants those GFCIs, like I said, to be anywhere where there's water, and sometimes it's in the permanent wiring, so you'll see that in a plug in that picture there, or maybe actually in the wire. Static electricity is another hazard, and you're probably all familiar with static electricity. It can build up and it can cause a shock. It can also, depending on what you're working with, it can cause a hazard, and that little shock that you get, like if you're walking through a carpet, can also be discharged, and if there's some sort of flammable liquid or combustible dust there, an explosion can occur. At BPI, we don't really have a big concern about that because most of the materials that we're handling are minerals, so that the concern about any sort of combustible dust is not a big one, but still static electricity is present and is a hazard. So here's an example of the three wires, and we'll talk a little bit about electrical shock. Basically, the shock occurs when your body becomes part of the circuit. Current enters at one part of your body and leaves in the other. So basically, you become part of the wire. In tools and other machines, there can be electricity, obviously, to make them work. And anywhere where there's a break in the insulation or a short in the material or the equipment, you can get an electrical shock. The way that we try to install our equipment, we make sure that that doesn't happen, but still, if there's not proper insulation, you can get shocked. A shock, hopefully you've not ever had a shock, but most people probably have. You can feel that it's slight tingling, but a bad shock can be very bad and can even kill you. Wet conditions, because the water can carry the electricity, can also cause a hazard and can get you killed. Electrical burns are also another hazard. And basically, if you get a bad enough shock, you can have a burn from the electrical, and it would just be like a burn from a flammable material. There are electrical burns. It's basically from the electricity. There's an arc or a flash burn. If there's what's called an arc flash from the equipment. Or there could also be thermal contact burns. If there's something hot or overheated on an electrical conductor, you can be burned by that way, and that means also. One of the other things that is not fun to talk about, and definitely less fun to get, is what's called involuntary muscle contraction. And basically what that happens is if a person touches something that has a high voltage, they can actually have their muscles be frozen on that piece of equipment, and they can't let go of it because their muscles are contracted around it. And what happens then? Well, they're there, and they're stuck to it. And if they're, as it says there, if they're frozen to it, don't try to pull them off, because obviously they're in the electrical circuit, and you don't want to become an electrical circuit. The biggest thing to do is to turn off the power if you can, or they talk about using a stick or a pole or something made out of something that doesn't conduct wood, a dry piece of wood like a 2x4, and push the person off of the current. Obviously, that's a dangerous thing and something you have to be careful about. And certainly, if any of these things happen, then you would immediately want to call 911 and get medical help. Falls are a big hazard as far as electrical, because what happens is people are working on something at height or somewhere, and they get an electrical shock. They automatically pull away, and then they fall down. So that's another hazard you have to be careful about as far as electricity. Other dangers, we talked about fires from arcs, explosions from flammable gases, flammable vapors, or combustible dusts, and equipment and machinery which explodes, sending fragmented metal in all directions. Hopefully we'll take care of our equipment and those kind of things don't happen. So some of the causes of electrical injuries and some of the safety rules. As far as contact with power lines, stay away from the power lines, particularly in large equipment. With a bucket truck or a front end loader, make sure that you're down lower and aren't anywhere near the wires. You need to stay at least 10 feet away from the overhead lines, and assume any line you see, whether it's in the sky or on the ground, has energy in it. If there is an electrical problem, if a wire falls down, you'll see sometimes what happens is the wire will be laying there, but then the system will try to re-energize to get itself back up again. And sometimes those lines will start right back up again. So you have to be careful about that. And then also the GFCIs, the ground fault circuit interrupters, make sure that they're in place whenever there's a hazard for a wet area or an area where there may be a shock. Make sure anything's grounded properly. So all of the wiring we have should be grounded properly, and the electrical circuit should be grounded. If you see something that's not quite right in the ground, or if you have a piece of equipment that has ground prong missing, make sure you let the plant manager know that we can take care of that kind of problem. And then make sure you use equipment properly. Multi-receptacle boxes, you should be careful of those. Running extension cords in areas where they could be damaged. Using indoor equipment outdoors can be a hazard. Using 2-prong adapters on 3-prong cords and tools. Using circuit breakers or fuses that have the wrong rating. Using cords which have worn insulation, exposed wires. Also, make sure you use proper extension cords properly. Don't ever use a factory assembled cord. If it's in danger, make sure or if it's damaged, make sure you get rid of it. Use only three wire extension cords that are for hard or extra hard usage. Make sure the cords are used properly. When you unplug a cord, pull the plug, not the cord. Make sure that if you see any cords that are damaged, like the one in the picture, that you get rid of them. When a portable generator is used, just make sure they use that properly, follow the instructions. I don't think that's a big concern here, but just make sure they use properly, and they should never be used indoors because it is a gasoline engine. PPE, make sure you use a proper PPE whenever you're doing any sort of electrical work or working around electrical things. And generally, this is not a big thing that we do here, and generally we rely on electricians to do any kind of electrical work, so we don't have to have concerns about that. Lockout, tagout. The most important thing about lockout, tagout, if there's a lock or a tag on it, leave it alone. If you have any questions about a piece of equipment that has a lock or tag on it, and it's not yours, then make sure you let somebody, a supervisor or plant manager, know that you have a question about it. And that's about it. Just make sure that safety is an important thing around electricity. There's a lot of danger from electricity, a lot of electricity around, so just make sure you use it properly. If you have any questions, make sure you ask your supervisor, plant manager, or certainly let me know. Thanks a lot.